Hey guys, and welcome back. Thank you so much for staying tuned the whole way through the show. I'm here to take the last question. Congratulations to Brandon for winning your brand new TV. It's that easy, guys. Just send in a question on topic for that week that involves your name, face, the question, and you could win such great prizes like a 19-inch TV, data, airtime. We'd love to hand out these prizes to you guys, so send in your questions. We'd love to hear from you. For now, we have the last question that I'm going to take for the day, and it's from Tiamo. So let's see what she has to say.
Hi Tenfold, my name is Amo and I'm from Maragon. Could you please help me with this question? Thank you.
Thanks, Amo. That's a really great question. It's basically just testing your ability to apply the understanding that you've gained, guys, about factor theorem, remainder theorem. We're just going to jump right into it. It's a fairly simple question, but it's got a lot of different techniques we can use, so I'm really keen to solve this question with you guys. Let's have a look at it. It says, which of these three divisors given for the equation is a perfect factor of that equation? Okay, so we have our function equation here, and we're given three different divisors. The fact that they say perfect factor, guys, that should immediately ring bells in your head. Because we've been doing remainder theorem and factor theorem, you should know that if something's a perfect factor of a polynomial, the remainder is going to be 0. If something divides perfectly into something else, there's nothing going to be anything left over. There's going to be 0 left over, no remainder. Okay, so what we have to do here is divide each of these divisors into the polynomial that we've been given and see which one yields a remainder of 0. But bear in mind, guys, if 1 gives a remainder of 0, it doesn't mean it's the only factor. Because this is we've got a quadratic polynomial here. Because it's quadratic, we could have two different answers that yield a remainder of 0. Okay, so bear that in mind. So let's just jump right into it. I'm going to use long division for the first one, just because it's nice to get some revision in for long division. Okay, so let's test A. To set up long division, okay, we're going to use this divisor, which is x plus 2, and we're going to set up our polynomial in here. So we have 6x squared plus 11x minus 2. Okay, so long division, daddy, mommy, sister, brother, divide first. We say 6x squared divided by x is 6x. Then we multiply, so we get 6x squared, and 6x multiplied by 2 is 12x. Okay, now we subtract these two. Okay, so that gives us 0. 11 minus 12x is negative x, and then we bring down. And then we start the process all over again. So we start with divide again. Negative x divided by x is negative 1. We then multiply. So we say negative 1 multiplied by x is negative x. Negative 1 multiplied by 2 is negative 2. Okay, so now we subtract these two, and we see that we get a remainder of 0. Ha! Perfect, guys. Remainder theorem. We have a remainder of 0, which means that this divisor is a perfect factor of the polynomial. Okay. So that means that A is definitely a perfect factor. Use a better color there. Okay. To test the next one, I'm going to go through my favorite type of division, synthetic division. Okay, so we're working with this divisor here. But remember, guys, that's saying that x minus 2 is the factor that equals to 0 if it was a divisor. So if we wanted to use synthetic division, we have to say that x is equal to positive 2. Okay. So to set up our synthetic division, we take the divisor that we're using, little dividey bracket thingy, and then we use the coefficients of our polynomial. Okay, so we have 6, 11, and negative 2. Alrighty, so first thing we do with synthetic is we bring down that first coefficient. So we get 6 there, then we multiply. So 6 multiplied by 2 is 12. We add these two together and we get 23. We then multiply again, which gives us 46. And negative 2 plus 46 is 44. Okay, so remember what this means, guys. It means that we have our original divisor here, and these are the coefficients of our next bracket. So we have 6x plus 23. Okay, And that's what's going to give us our original polynomial. But because this isn't 0, guys, we have a remainder of 44. And because that remainder isn't 0, guys, it means that that divisor doesn't completely divide into that polynomial that we're given. It divides into it, but then we have leftovers. It's like when you do fractions in grade, I'm assuming like 5 now. When you do fractions, guys, you're going to get an improper fraction. You're going to have a whole number and then a little bit left over, or a mixed fraction. Okay, so that remainder means that it is not a perfect divisor because there's a bit left over. It doesn't divide in nicely into our polynomial. Okay, so B is definitely not a perfect divisor. And for the last one, I'm going to use that theorem that I said earlier. Remember I said that if a polynomial is divided by a divisor ax plus b or minus b, then the remainder is the function of b over a. Okay, so here, if I substitute this whole thing into the function that we have and I get a remainder that's not 0, it means that that is not a perfect factor. Okay, so here, a, if I'm looking at this format over here, guys, a equals, in this divisor, 5, and b equals 1. Okay, so we're trying to look at f of 1 over 5. Okay, so let me just scroll down. Let me double check. 6x squared plus 11x minus 2. 6x squared plus 11x minus 2 is the polynomial that we're given in the first place. Okay, so we're trying to find f of 1 over 5. So if I substitute that in, I get 6 multiplied by 1 over 5 squared plus 11 multiplied by 1 over 5 minus 2. Okay, so that gives me 6 over 25 plus 11 over 5 minus 2. Okay, so now to add them all together, like denominator, we get 6 plus 55 minus 50 all over 25. Okay, which gives us 6 plus 55 is 61, minus 50 is 11 over 25. Okay, so what we've worked out is the function value of that divisor that we're working with there. Okay, and since the function value of that divisor is a number, it's not equal to 0, it means that it has a remainder, there's a leftover bit. And remember what I said, if you divide something into something else and there's something left over, it means it doesn't divide into it wholly, which means it's not a perfect divisor of that polynomial. Okay, guys, so hopefully these 3 methods have helped you out, helped you understand your remainder theorem. Let's just mark that off there. So only this one here is a perfect divisor. Okay, so guys, hopefully today's show has helped you out with this stuff. I really like this question. It's very simple, but it's really nice to try and just integrate your theory, help you understand where you need to divide, how you can divide. There's so many different options. Hopefully I've helped you understand the remainder theorem from the perspective of if you substitute in the divisor into the function and get a remainder, it means that it doesn't divide in. Okay. So if you get a divisor, guys, and you don't want to use long division or synthetic division, you can cheat and basically just substitute that divisor into the function. If you do that and it comes out with a number, means there's a remainder. Okay. If it's 0, there's no remainder. Okay. But thanks for tuning in, guys. It's been a great show. We've loved having you here. Send in your questions for calculus next week, guys. We're here to help you. And tune in next time tomorrow. Bye for now.